2.11. And what we're supposed to do is, without using a calculator, so make sure you're being careful there. So with no calculator, let's see if we can answer these things. Now, at the very bottom, you see it says graph them. And these, I generally start with the graph, and then I answer these questions. Okay. So let's start with this natural log function. So I'll draw the parent function here, and then everything will be kind of based off of that. So there's the parent function. It looks something like this. Okay, you know what? Let's go ahead and generate a few of those values there, so you can remember where they all come from. So let's do log base 10 of x, and let's make a little x, y table. And the first number we'll plug in there is 1, and out comes a 0. So 10 to the 0 power gives me a 1. That's what we're saying. Then I could plug in like a 2 for x, but I don't know 10 to what power gives me 2. So the next number you plug in is like 10. And then you go, okay, so 10 to the first power. Then you plug in 100. And you get out 2. So you're like 1, 0 is on your graph. And then 10, 1 is. So way out here at 10, you get 1. And then you can plug in like 1/10, but 1/10 gives you -1 for your exponent. So at 1/10, your y value is at -1, and that's your asymptote. So they sit in here just like that. Okay, and so you'll see me draw those things frequently because that's how all logarithms look. That's a base 10, 1, base 2 is pretty much the same thing. Of course, its ordered pairs are a little different. Parent function. So let's draw this new function. Okay. And let's see here, he's going to be shifted left by 8. So that's going to move my asymptote way out here to just -8. So you draw your new asymptote there. And he's shifted up by 3. So it's basically the same graph. It's just going to be moved up higher. So you just grab that part and move it up. So it looked higher. But that's it. Okay, so now we can do the asymptote. X is equal to what? -8. The domain. X is greater than the -8 because it's going to the right. Its end behavior as x goes to the right, it goes up forever. So the function goes up. But as x goes to the, now on the left-hand side, it's approaching -8. On the positive side, and the function goes down to -infinity. Terrible. -infinity. There we go. Oh, and our range is all real numbers, so -infinity to +infinity. And I'll go ahead and write our domain here in interval notation as well. And there we go. So let's do number 2 here. All right, problem number 2. So let's see here. We got a shift left 6, a down 4, and this is a reflect over x-axis. So it's going to go upside down. So my graph, left 6 units and upside down. So over here at -6, and it'll be upside down. So like that, or something to that effect. So again, I'm just referencing this drawing right here. And so you can see if I were to reflect that thing upside down, it looks something like this guy. Okay. But then it's translated over there to the left by 6. So there's our description of it. Let me get rid of some of that. Or a graph of it. Asymptote, x equals -6. Domain, x is greater than -6. I didn't mention I did shift it down 4. It doesn't look like it, but pretend it is. Shifting it up and down does not change your answers to any of these questions. End behavior, as x approaches -6 from the positive side, the function goes up. And as x goes to +infinity, the function goes down. So the y values are getting more and more negative. There we go. Now problem number 3, we're going to do a little reworking here. Log of negative x plus 4. Then we want to pull that negative out so it looks like this. Negative of x minus 4. So this is going to be a right 4 and then a reflect over y-axis and then down 14. Alright, so let's draw a graph of this thing. So he's going to go right 4, then it'll be flipped over, so he's going to be sitting like this guy. And then he's going to be shifted down 14, so really he's way down here and maybe doesn't cross till way later on. But he still has this general shape to him. Okay, that's probably kind of poor, probably just something more like this. But regardless, you kind of get the idea just with that purple one. That's all we're really concerned with. The asymptote here, x equals, where's that at? 4, x equals 4. Domain now x is less than 4. And behavior as x goes to negative infinity, this thing goes up forever. But as x goes towards, let's see, it's approaching 4 from the negative side. This function goes down to negative infinity. And our range, negative infinity to positive infinity, and interval notation, negative infinity up to 4. See, I don't think I did my interval notation for number 2, so this would be from negative 6 to infinity, like that. Now our last problem, question number 4 here. Let's see what we got going on here. So we certainly are going to be x reflected. So upside down. See, this becomes negative x plus 12, which is negative of x minus 12. So there's a y reflection. And right 12 and up 47. So let's see if we can get this graph right. So I gotta be concerned about this right 12. And it gets double flipped. So it's going to get flipped reverse. So it'll be flipped like this. And then that's going to be flipped upside down like this. So our graph will look something like that guy. There we go. Asymptote x equals 12. Domain x is less than 12. And behavior as x goes to negative infinity. This function goes down. As goes to the right, it stops at 12, so it hits 12, approaching it from the negative side. This function goes up to positive infinity, and our range, all real numbers. And our domain as an interval, negative infinity to 12, like that. And I believe that takes care of section 2.11.